Hello, my dear students. Welcome to the Quantitative Methods for Economic Analysis 2 classes. In last one semester, we were discussing some of the basic statistical analysis as well as certain mathematical tools. Okay, and in this semester, what we are going to do is we are continuing with our statistical analysis. Unlike the previous semester, in this semester we have only the portion from the statistics, okay, and we don't have any portion from the mathematics. This semester we have only 4 modules. Okay, the first module is the module about index number and time series analysis, and those who have completed a +2 in their humanities or commerce, they might have learned the index number but they may not have learned this time series analysis. Okay, so we have basically this time series and index numbers are 2 different chapters dealing with 2 different things, but in order to reduce the chapter number or in order to reduce the number of module, we have combined all these 2 chapters, index number and time series, into one chapter. Okay, so in this chapter we will discuss what is an index number and how we are constructing an index number. Okay, and how we can use different kind of weighted index numbers like last pairs, passengers, Darby's and Bowley's index number, Marshall's and Edgeworth, Kelly's index number. Okay, then after that we will discuss, or we will come to the second part of this first module, time series. Okay, what is a time series? What are the different components of time series? Okay, and how we can measure the different components of time series such as trend, seasonal components, cyclic component, irregular component. How we can measure all these kind of things. Okay, and after this module, we'll come to the part of this mathematical statistic. The first module is basically a part of the descriptive statistics, but the second module onwards, we will move into the mathematical statistics, where we will use statistics with more mathematical techniques, or we will use more mathematical tool in the second chapter onwards. Okay, so it's a chapter about the probability, and those who have completed +2 science program, they might have learned this concept, probability concept. Okay, and those who have completed CBSE syllabus also, they have also learned this probability concept. Okay, so it is a very simple chapter but more powerful chapter. Okay, and it is the basis of the further statistical analysis. Okay, if you want to go further and if you want to learn statistics, if you want to learn econometrics, and this probability will be the fundamental basis of the mathematical statistics. Okay, so this is in this chapter we will learn certain basic concept about the probability and how we can solve certain probability problems using certain theorem called the multiplication theorem and addition theorems. Okay, and we will also learn certain thing about the joint probability and the conditional probability, and we will learn this Bayes theorem. Okay, so that's all about this second module. And the third module is basically an extension of the probability. Okay, so in this chapter we will learn certain probability distribution like binomial and Poisson and normal probability distributions. Okay, and the last chapter deals with how we can solve all the theories or all the method that we have learned in this semester and previous semester using a software called MS Excel. Okay, so certain tools in MS Excel I have already demonstrated. Okay, and more of this will be done in this fourth chapter. Okay, so in fourth chapter we will learn all kind of basic statistical tools that is available in MS Excel softwares and how we can do the statistical analysis using MS Excel softwares. That's all about that will be dealt with in this last modules. Okay, so we will start with the first modules. Okay, and we will go with second, third, and last modules. Okay, so in the first module, it's all about this index numbers. Okay, so what is an index numbers? I will demonstrate what is an index number using a real examples. Or with the help of an example, I will show you why we need an index number and what is an index number. Okay, so look at this table. These tables give us certain commodities and their prices in two different periods. The commodities are rice, sugar, petrol, milk, clothes, gold, and egg. Okay, and their price has been quoted in two different periods, 2000 and 2019. Okay, so rice price was 800 per quintal in 2020, 2000, and when it comes to 2019, it is around 3000 rupees. Okay, so if you closely look at these tables, we can observe that the price has been drastically increased. If you look at all the commodities, we can, at a glance, we can say that the prices of all these essential commodities has been increasing. All these commodities are essential commodities and all the prices has been increasing. Okay, so when we make this kind of a statement, we may have three different questions in our mind. We may have three different questions in our mind. What is the questions? The first question is, the prices is increasing. Okay, and you can see that in 2019 all the price has been increased compared to what year? Okay, so the first thing is we need a two time period or two different time point to tell whether the price is increased or decreased. Okay, so whether the price is increased or decreased, we can only tell or we can only say on a basis of comparison compared to the 2000 year prices, whether the prices in 2090 has been increased or decreased. Okay, so the first thing what we need to tell whether the price has been increased or not is two different years. The first year is known as, or the current year is known as, or in statistics this in this the price in 2090 is known as the current year. Okay, and the previous year is known as the base year. So this is what is called the base year, because we are comparing these prices with these prices. Okay, so this price is known as the base year prices. Okay, and this is known as the current year. Okay, so we always compare the current prices with the previous prices. Okay, so the previous prices will always known as the base year, or the prices known as base year prices. Okay, similarly, if you look at this commodity prices, we have stated that all this price has been increased or increasing. Okay, But if you look at each commodity one by one, we can say that the price has been increased, but not in a similar rate. Different commodity price has been increased at a different rates. Okay, if you look at the rice per quintal, it was 800. Okay, so now it is 3000, almost four times. The prices of rice has been increased by four times. But if you look at the sugar, it was 15, now it is 38, only 2 point something times. So, well, 2.3 times. Okay. Similarly, if you look at the petrol, it was 105, now it is 294, almost 2.5 times. Okay. But if you look at the milk, it was 8, it is increased by 5 times. Okay. And if you look at the clothes, it was 235, but now it is 195. It has been decreased. A marginal, it has been decreased, not half of the percentage, but only a marginal decrease has been happened for the clothes. Okay. So what does it mean? If we state that the price has been increased in 2019 compared to 2000, okay, so it doesn't mean that all the commodities price has been increased at a uniform rate. Okay, there may be decrease or there may be increase. Okay, and this increase or the decrease may happen at a different rates. Okay, yes. So that's the second things. The third thing is, if you look at the different commodities, all these commodity prices has been quoted in different units. The units of the price or unit of the commodity has been different. Rice is measured in quintal, sugar in kilogram, milk in liter, clothes in meter, gold is in gram, and egg is in dozen. Okay, so it tells us that all these prices have been measured on different commodity unit. Okay, so can the prices of different goods be expressed in a single standard units? Okay, so there are three different questions. Okay, the first question was compared to which year the price has been rise. The answer was 2000 prices. Okay, second question, whether the price of all commodity are increased or price of some commodity have increased more than that of other. We have seen that almost all the commodity price has been increased, but their rates of increase has been different. Okay, and one commodity is not increased but decreased. Okay, and the third question was there are different commodities and all these different commodities has been increased in a different way, and all these commodities has been measured on different scale or different units. Okay, so how you can say that the prices of these commodities are increased? Okay, for these questions we can answer for this question using a technique called the index number. Using an index number, we can answer these questions. What's the question? Whether the price of this commodity has been increased or not. Okay. Regarding the first question, rises in price of during 2019 can be studied only if any other previous period is given or any other reference period is given. Okay, it means that for a comparison purpose, if we want to compare the prices of any commodities, okay, we need two different periods. Okay, otherwise the statement would make no any sense. Okay, so without making any comparison, we are just simply saying that the price has been increased. It's make no any senses. Okay, so here we want to measure the increases in the price in 2019 compared to 2000. Okay, so this 2019 is the current year and 2000 is the base year. Okay, and in index number, what we usually do is we will consider the base year reference period or the base year as the 100, or we will assign the value 100 into a period base year. A base year value will be always taken as 100. Okay, yes. Regarding the second question, with regard to the second questions, okay, index number will measure the average changes. Okay, so when price of some goods are increased more than that of the other goods, we will take the average price changes. Okay, so the statement the prices of these commodities has been increasing is only based on the average changes. Okay, there may be increase or there may be decrease. Sometimes the increases in one commodity may be more than that of the increases in the some other commodities. But when you make a statement like the prices of the commodity has been increasing, it is an average statement. Okay, yes. And regarding third questions, index number will measure the average, not only the average changes, but the average percentage change. Average percentage change. Okay, so when we express the changes in percentage or relative terms, the unit of measurement loss its relevance. Okay, so when we are expressing the changes in percentage, then there is no relevance for the unit of value. Okay, so there is the measurement when we measure the changes in the average, still there is a scope for the unit. But when we are measuring the changes in the average percentage changes, then unit of measurement will lose its relevance. Okay, yes. So what is an index number? An index number is a statistical tool which measure the percentage changes in the level of a certain phenomenon or value of a different variable in any given period called the current period with respect to its value in some fixed period called base period. Okay, so an index number is a statistical tools that help that measure the average percentage changes in the price in any phenomenon or any value of a different variables. Okay, this variable can be prices or the quantities or volume, any whatever it may be. Okay, so this index number will measure the average percentage changes in two different period, current period as well as base period. Okay, so in this definition we have said that measure the percentage changes in the level of a certain phenomenon. Okay, so or the phenomenon or the value of different variable. Okay, so the phenomenon or the variable may be the price or the quantity or the volumes. Okay, so it may be the price of a particular commodity or a group of commodities. Okay, or it may be the quantity of a particular commodity or a group of commodities, or it may be a volume of a particular commodity or a group of commodity, or a volume of trade or volume of production, import, export, stock markets, or shares, sales, or profit, whatever it may be. Okay, so what is an index number? Index number is a statistical tool, it's a statistical method that measure the average percentage changes in the level of price, quantity, or volumes, okay, in any particular period of time with respect to a previous period. Okay, so that is all about the index number. Okay, So if you look at this an economy, or if you look at the reality, we can say that there are large number of different index numbers are regularly used by different economists or different officers of economics. Well, just like RBI is using, then various governments are using, okay, then stock markets are using index numbers. So if you look at any officer that deals with some kind of economics or economy, they are using certain uh, indexes. Okay, so the first index number was constructed by Carley in 1764. Okay, so what he has done, he compared the changes in the price for the year 1950 with the price level of 1500 or 1500. Okay, so he has compared the prices in 1500 to 1750. Okay, so in order to measure, or in order to study the effect of discovery of America on the price level of Italy. Okay, so what will be the effect of the event, the discovery of America, on the price level in Italy? Okay, so in order to do that one, he has taken 1750 as the current period and 1500 as the base period, and he compared the prices between these two periods. Okay, yes. So um, for index number, okay, there will be three specific features are there. Okay, so first one is the index number will measure the relative changes or percentage changes. Okay, so in the previous semester we have learned many kinds of different kinds of averages. Okay, like mean, median, mod, or some many averages. Okay, so all these averages were in absolute averages. Okay, whereas the index number will measure the relative average, which means that it will measure the percentage changes, the averages in percentage. Okay, similarly, index number will measure the quantitative changes, not the qualitative changes. So index number is constructed purely for the purpose of measuring quantitative changes, not in qualitative changes. Okay, and last one is index number are basically the averages. Okay, so index number is basically an average, but not a mere absolute average, but a relative averages. Okay, and that will measure the quantitative changes. Okay, yes. So let me take an example of let me take an example. So here let me take an example. Example is, what percentage of the population in 2040 has increased since the year 2000? Okay, so we have different populations in different years. From 2000 the population was 98 crore, 2001 100 crore, 2002 100 crore, 2003 107 crores, and 2004 110 crores. So what we want to find out, we want to find out how much percentage population has been increased in 2004 compared to 2000 populations. Okay, so here we want to find out the population changes, the percentage changes, average percentage changes in 2004. So 2004 will be our current year. We want to compare this population increases on or based on 2000 population. So 2000 will be our comparing prices or comparing year, so it will be our base period. Okay, so if you look at this population chart, we can see that the population has been increasing from 2000 onwards. Okay, yes. Now, how we can find out how much population has been increased? For this purpose, we can construct an index number. Okay, so a simple index number will look like this. It is value in the current period divided by value in the base period, and we will convert this into 100. Okay, so you look at the first, the value in the current period is 98. We are comparing the value with the same values. Okay, so here the current value as well as the base year value is same, 98 and 98. So 98 divided by 98 is 1, and 1 into 100 is 100. Okay, so that is why we are saying that the index number for the base year will always equal to 100. Okay, so in 2001, 100 minus 98 into 100, 102.04. Here 104 divided by 98 into 100, 106.12. Here 107 divided by 98 into 100, 109.18. And here 1110 divided by 98 into 100. Okay, so what is all these things? These are all different index number for different period. Okay, so when we take, how we got this 102.04? 102.04 we have got it by considering 2001 as current and 2000 as the base year. Okay, but what was the question? Our question was 2004 year and compared to 2000. Okay, how much population has been increased? Okay, so here we have got 112 in 2004 and compared to 98 2000 population, we have got around 112.24. What does it mean? Is there an increase in population by 112 percentage or 112 percentage? No. Okay, so in 2004 the population increases is 112.24. In 2001 it is 100 percentage. Okay, so from this 100 percentage there is an increases by 12.24 percentage. Okay, so 12.4 percentage, 12.24 percentage increases has been incurred in total population between 2000 and 2004 populations. Okay, similarly, what will be the percentage changes in the population between 2003 and 2004? It will be 112.24 minus 109.18. Okay, so all these points are known as index points or index number. Okay, yes, so this is what we called an index number. Index number is constructed by dividing the current values with its base year values and multiply with 100. This is the simple index number. Okay, so there are different types of index number. Okay, so we can broadly, the index number can be divided into 3 categories. Okay, the first one is the price index, second one is called quantity index, and third one is called volume index. Okay, so broadly the index number can be divided into 3 categories: price index, quantity index, then volume index. So what is price index? Price index measure the relative percentage changes in the prices of a commodity or a basket of commodities consumed or produced in the given period of time with reference to the base period. So price index, as the name indicates, measure the average percentage changes in the prices of a particular commodity or a group of commodity within 2 years. Within 2 years. Okay. So this price index can be single price index number or a composite price index number. What is the single price index? Single price index means comparing the prices of a single commodity between two time periods. What is composite? Composite means comparing the prices between a group of commodities 2 years, in 2 years. Okay. Yes. So if you look at this tables, you can see that the real petroleum prices in India from 2005 to 2010. I want to compare how much petroleum price has been increased in subsequent years compared to 2005 year. What I have to do? I have to convert the prices of the petroleum in 2005 into 100. How I can convert it? It is nothing but current price divided by base year price into 100. Current price is 44.26 and we are comparing it the same year. So it is 44.26 divided by 44.26 into 100. So it would be 100. Okay. Now if you look at what you can see here, 2005 to 2006, two years, we are comparing the prices between 2 years for the one commodity. Here the one commodity is called petroleum products or petrol prices. Okay. So in between 2005 and 2006, the petroleum price has been increased by 117, which means that 17.10 percentage. 17.10 percentage. Okay. So between 2007 and 2005, 107 percentage. Between 2005 and 2010, 17.18%, 78 percentage. Okay. So different period of times, the price of petrol has been increased and in some years has been decreased. Okay. So overall we can say that in between 2005 to 2010, the price has been increased to 117 or 17 percentage. Okay. 2005 to 2008, 12 percentage. 5 to 7, 7 percentage. In that way we can interpret this result. So this is a simple index number. It tells us whether the price has been increased or not for a single price, okay, or single commodity. Now, what is the composite index number? Composite index number. If you look at the newspaper, you can see that wholesale price index number, consumer price index number, CPI, WPI, okay, or PPI, producer price index number, or index of industrial production. Okay. Similarly, nominal real effective exchange rate, you can see this kind of lots of indexes. Okay. So basically these are all certain kind of index number. It will measure the average percentage change in their average percent change for a group of commodities. Okay. So for example, if we look at this earlier tables, you can see there are large number of different commodities. Okay. And we can find out whether the prices of this commodity has been increased in two different periods, 2000 and 2019. Okay. So here I am comparing the prices of a group of commodity between 2 years. So this is what is called the composite price index number. Okay. So simple index number or simple price index number is we are comparing the prices of a single commodity between 2 years or between a number of years, different years. Okay. But in composite index number, we are comparing the prices of different commodities between 2 years. Then second group is called quantity index number, or second category is known as quantity index number. Okay. So in the first cases, we have compared the prices. Okay. Here, what we are doing, we are measuring the average price changes in the physical volume of goods consumed, produced, or sold in a given amount of year with uh, reference to a base year. Okay, so here we are not comparing the prices, but the quantity that we consumed, or the quantity produced, or the quantity that we sold. Okay, yes. So if you look at this table, you can see that it's a petroleum product that we consumed in trillion metric ton. Trillion metric ton. In 2013, India consumed around 1, 2, 3, 4, 5, 2 lakhs 59,035 trillion metric ton petroleum products. Okay, so in 2004 it has been increased. Okay, how much time? 2%, 2.33%. Okay, in 2005-15, 12%, because its index number is 112.8. Okay, in 2016, 127, 121.5. What does it mean? Compared to 2013, in 2016 there is an additional 21% increases in the quantity of the petroleum products. Okay, yes. The last one is the volume index or value index. Value index is nothing but it measures the changes in the value of a commodity consumed or purchased in a given period with reference to the base period. Okay, so value is nothing but the prices multiplied by the quantity. That's the value or volume. Prices multiplied by the quantity. Okay, so if you look at this table, you can see that the 2013 and 14 we have used around 2,59,335 trillion metric ton petrols. Okay, and the price was around 4.568. If you multiply both, the volume is 94 lakhs 0.771. Okay, so if you look at the index number, you can see that in 2014-15 compared to 2013-14, there is a reduction in the value of petroleum product. Okay, and further if you see that the total value of this petroleum product has been decreasing. It has been decreasing. Okay, so if you look at this, this will be 100 minus 81, 19% decrease. Okay, in 2005-15 it is around 49% decreases in the total value of this petroleum product. Okay, so this is all about different kinds of indexes. Okay, so broadly we can divide the index number into three categories. Price index again can be classified into single price index as well as composite price index. Okay, and the second one is the quantity index, and third one is the value index. Okay, yes. Now how we can construct an index number? Okay, so broadly there are two different methods to construct an index number. Okay, the first method is the simple index number. Okay, and the second one is the weighted index number. So there are two different broad way of constructing index number. First one is simple index number and second one is weighted index number. Okay, so in simple index number, all items in the basket of comparison has equal importance or weightage. Okay, so these are all two different types of index number. Okay, in first model or in simple index number, we will consider that all the commodity that is included in the commodity basket have equal importance or equal weightage. Okay, whereas in weighted index number, the commodity that has been included in our comparison basket have different weightage or different roles depending upon their relative importance. Okay, so there are two different kind of index number: simple index number or simple unweighted index number, and second one is the weighted index number. The difference is, in simple index number we are not assigning any weights, or we are not taking into account the relative role of this commodity in the commodity basket, whereas in weighted index number we are considering the different weights, or we are considering their relative importance in our commodity basket. Okay, yes. And the simple index number again can be uh, divided into single price index, aggregate price index, and average of price relative index. Okay, simple index again can be divided into single price index, aggregate price index, and average of price relative index. Similarly, the weighted index number is also can be divided into weighted aggregate price index and weighted average of price relative index. Okay, so what we do is we will analyze all these different types of index number. We will discuss it in detail. So first we will discuss what is the simple index number or what is the single price index number. Single price index number measure, as the name indicates, percentage changes in the price of a single item between two time periods. Okay, so single price index number, as the name indicates, it is comparing the prices because it is single price index and it is comparing only the prices of a single commodity. Okay, so as per this method, the price index number is equal to prices of nth of Pn divided by P0 into 100. What is this Pn and what is this P0? I will discuss, or I will tell you. Okay, so you look at an example. This is a price for a product from 2000 to 2003. There are 4 different years. We have 4 different prices. Okay, so all these prices are of the single commodity. Okay, so in 2000 the price of this commodity was 24.60. Okay, so this is price relative means what? 24.60 divided by 24.60 into 100 will become 100. That is called price relative. So price relative is nothing but current prices divided by the base year prices into 100. That is called price relatives. Okay, yes. So you look at the 2001, the price has been increased to 25.35. So 25.35 divided by the 24.60, that is the base year price, into 100. We will get 103.04, and this is what is called price relative. And what is the percentage changes? This is 100. Okay, this is 100 and this is 103. What is the percentage changes? 303.04. Okay, so what does it mean? Compared to 2000, the price of this particular single commodity has been increased to 3% in 2001. Again, if you take 2003, 26.50 divided by 24.60 into 100 is 107.72. Okay, so this prices compared to 2000 population has been increased by 7%, whereas compared to just previous year, it has been increased only by 2.03%. Okay, yes. So this is what is called a single price index number. Now, what is simple aggregate price index number? So simple aggregate. So as the name indicates, it measures the percentage changes in the prices, not for a single commodity, but for a group of commodities. Aggregate. Okay. So aggregate means what? Aggregate means there are a large number of commodities. We are taking the aggregate of all these commodity prices, and we are comparing this with the base year prices. Okay. So here we are taking the aggregate prices in the current period, and we are comparing with the aggregate prices with the base period, and we are telling whether there is a price changes or whether there is a price changes or not. Okay. So here in simple aggregate price index number, we are expressing the aggregate prices of all commodities in the current year as a percentage of the aggregate prices in the base period. Okay. So it is nothing but P1. P in index number 1 means current period and 0 means base period. Okay. So what is sigma P1? And this P0 means here we are finding out price index number for the current period compared to base period. So P01 means what? Price index number for the current period taking 0 as the base. Okay. Yes. So this sigma P1 means what? Summation. Sigma means summation. P means price. 1 means current period. So sigma P1 is summation of the prices in the current period divided by sigma P0 means what? Summation of the price in the base period into 100. Okay. So in index number notation 0 is stand for base year and 1 stand for current year. Okay. So how we can calculate the simple aggregate price index number? Okay. You look at an example. Here we have four commodities: milk, egg, butter, and bread. You look at this unit of measurement: milk in liter, egg in dozen, butter in kilogram, bread in pack. All these unit of measurement are different, but still we are able to find out the average price changes between these two periods. Two periods are 2001 and 2000. Okay, so here 2001 will be the current period and 2000 will be previous period or base period. So we have to compare the price changes between 2000 and 2001. 2001 will be the current period and 2000 will be the base period. Okay, so here the question is we have to calculate the simple aggregate price index number for 2001 using 2000 as the base year. What you have to do? You have to assign which one is P1 and which one is P0. The question clearly says that 2001 is the current, so this 2001 will be P1 and this will be P0. So what you have to do? You have to add all these prices. We are getting 199. You add all these prices, you are getting 1.162. You simply substitute this in the equation. So it will be 199 divided by 162 into 100. So it is 122.83. We are getting a simple aggregate index number 122.83. Okay, this 1.2283 is not in kilogram, not in dozen, but it is a number. Okay, so it is a relative changes in your prices between two periods. So it will tell us on an average the price of these four items has been increased by 28.89%, not 122 point. Okay, because here the base year will be always expressed in 100. So 100 plus So 122 minus 100, it is 22.83%. Okay, so on an average, the prices of all these four commodity has been increased by 22.89 percentage. Okay, okay, and so this is about the aggregate price index, simple aggregate price index number. Okay, so in the simple aggregate price index number and single price index number, yeah, one more term is there. Okay, so the third method is simple average of price relative method. Simple average of price relative method. Okay, so this method is an improvement over the aggregate price index number. Okay, because in this method it is not affected by the unit in which price are quoted. Okay. So this method, simple average of price relative method, is an improvement over the aggregate price index number, and it says that it is not affected by the unit in which the price are quoted. Okay. So under this method, what we have to do first is we have to obtain the price relatives. The price relative is nothing but price in current period divided by price in the base period into 100. So it is P1 divided by P0 into 100. Okay. Then what you have to do is after this you have to take the average price index. Okay, obtained by using any of the central tendency measure AM or GMs. What we have to do first, we have to find out the price relatives. After that, we have to find out its average using AM or GM. Okay, so how we can calculate it? Using AM, we can calculate as a sigma P1 divided by P0 into 100 divided by N. Okay. Similarly, using GM, we can calculate as sigma log P1 divided by P0 into 100 divided by N, or anti-log of sigma log P1 by P0 into 100 divided by N. Okay, so in earlier we have just divided by sigma P1 divided by sigma P0 into 100. Here what we are doing is, after finding out price relative, we are taking the average of that by using AM or GM. Okay, yes, yeah. So first, let me take an example of how we can calculate the simple average of price relative method using AM. We look at an example. Here there are 5 commodities PQRST, okay, and their price has been given in 2007 and 2008, and we want to construct an index number for the year 2008, taking 2007 as the base period. Okay, so here what we have to do first, find out the price relatives. Okay, so this is the current period 10, previous period or base period 6, 10 by 6 into 100, 167. This is what is called price relatives. Okay, and 2 minus 12 into, yeah, similarly we can find out it is 16.67. Here 150.0, 120, 150. Okay, yes, if you take the total of this thing, it will take around 603. Okay, so sigma P1 divided by P0 into 100 is 603.37, 603.37. Now what you have to do? You take the average of these things. It is 603.37 divided by 5 is equal to 120.63. So what you have to say? Between 2007 and 2008, all these commodities called PQRST has been increased by 20.63 times, or 20 percentage increases has been occurred in the price of all this commodity between 2008 2007 to 2008. Okay, so this is the method, simple average price relative method using arithmetic mean. Okay, similarly we can also find out the same thing using GM. What we have to do for that? The same method. Look at this five commodity A, B, C, D, their prices in 2007 and 2008. This will be the current period and this will be the base period. Okay, so find out the price relatives. 2000 divided by 1800 into 100, it is 111.11. Okay, then you find out the price relative for all these commodities. Okay, then you find out the logarithmic of these price relatives. Log 111.11 is equal to 2.0457. Log 120 is equal to 2.0792. Okay, then what you have to do after finding out the logarithm of all these commodities, you sum of this logarithm. It is 10.48. Now you just give this in equation. What is equation? P01 is equal to anti-log of 10.4856 divided by 5. It is equal to 2.0971. So it is anti-log of 2.0971, which is equal to 125. Okay, so between 2008 and 2017, these five commodity prices on an average increased by 25%. Okay, so this is the simple average price relative method using GM. Okay, so far we have learned three different techniques. First one is single price index number. Second, simple aggregate price index number. Third one, simple average price relative index number using AM and GM. Okay. Yes. Yes. So in all these cases, in all this discussed method, we have not assigned weights, or we have not considered the weights associated with this commodity. That means how much commodity you have purchased, that we have not considered. We have only considered what is the prices without considering how much, or without considering the relative importance of these commodities in the consumer basket. Okay, so this method is basically an unweighted aggregate price index number. This is having three different limitations. Okay, the first limitation is commodities are weighted according to their prices. So the highly priced goods will have more impact on the overall index number. Okay, so here we have not considering the how much unit that we are buying. Okay, we are simply using the price as the major input for constructing this index number. So highly priced values or highly priced commodity will get high weights. Okay, for example, ornaments, we are buying an ornaments. Okay, so its price is very high, but we will only buy this in once in a year. But if you take the rice or sugar, okay, its price is very low, but we buy it regularly. Okay, so in a consumer basket, the importance of rice is much higher than that of the ornaments. But if you are not considering the weights, if you are not considering the commodity, how much unit that you are purchasing, then this prices of this highly priced product will get more weights. Okay, so second thing is the relative importance of the various commodities are not considering, and all commodities are giving equal importance. Okay, so in this method we are not giving any weights or any without considering the importance of this commodity in the consumer basket, we are giving all equal importance. Okay, yes. So here the price of various commodities are included, may be quoted in different units. Okay. Similarly, in this method, we are not considering the unit of measurement. Okay. So whatever may be the unit of measurement, we are considering it as the same. Okay. So these are all some of the demerits of the unweighted price index number. Okay. So this is a problem for you. Okay, so using these problems, they say five commodities are there: wheat, ghee, milk, rice, and sugar. Its prices in 2004 and 2020 has been given. So you have to find out you have to construct. Okay, uh, you have to construct simple aggregate price index, simple aggregate price index number. Similarly, simple relative price index number using AM and GM for all these commodities. Okay, so this is a problem for you. You solve it and send to this WhatsApp group. Okay, so today we have discussed certain basic idea about the index number, why an index number is necessary, that we have discussed first. Okay, then what is an index number, who constructed the first index number, then characteristics of an index number, then types of index number, price index number, quantity index number, volume index number, then different how to construct an index number. First one, how to construct an unweighted index number. There are three methods: single price index number, aggregate price index number, then aggregate price relative method index number using GM and AM. Okay, so all these things we have discussed in this class. Okay, and tomorrow or in the next section we will discuss the weighted index number. Okay, so thank you.